Welcome to the lesson on Introduction to Linear Equations in Two Variables. At the end of the lesson, you will be able to identify a linear equation in two variables and find a solution for a linear equation in two variables. What is a linear equation in two variables? An equation of the form ax plus by plus c is equal to 0 is called a linear equation in two variables. Okay, how can we say that this is a linear equation in two variables? This equation can be represented as follows. The equation is called linear because the equation is of the first degree. There are two variables in the equation, namely x and y. Such an equation is called a linear equation in two variables. Here are some points regarding the linear equation in two variables. A and b are called coefficients of x and y. C is called a constant term. A, b and c are real numbers. And in a given linear equation, both a and b should not be equal to 0. Now let's see some examples of linear equations in two variables. Can we say that this is a linear equation in two variables? Let's try. We will rearrange the equation and see if it resembles the standard form ax plus by plus c equals 0. This equation can be represented as follows. Now let's check whether it matches the standard form. Now we can say that the equation is a linear equation in two variables, where a is equal to 1, b is equal to 1, and c is equal to minus 5. Now see this equation. Can we say that this equation is a linear equation in two variables? Of course, yes. Let's see how. Compare this equation to the standard form. Now you can observe that the equation is a linear equation in two variables, s and t, where a is equal to 0.5, b is equal to 2, and c is equal to 0. From this example, we can observe that the variables are s and t. Usually, x and y are represented as variables for convenience. From the examples, we can conclude that an equation which can be put in the form ax plus by plus c equals 0 is called a linear equation in two variables, where a, b and c are real numbers. So far, we have learned how a linear equation in two variables is represented. Let's understand the equation better. So far, we've seen that a, b and c represent real numbers. We have also seen that x and y represent variables in the equation. Now, are we left with anything in this equation? Yes, the equal to symbol. This equal to symbol signifies that the left-hand side value of the equation is equal to the right-hand side value of the equation. Let's understand this with an example. For what values of x and y will the left-hand side of the equation be equal to 12? If we substitute 2 in place of x and 2 in place of y, we will get the left-hand side as 12. Let us see how it is done. Now the left-hand side of the equation is equal to the right-hand side of the equation. So we call 2, 2 a solution of the equation. In other words, we can say the ordered pair 2, 2 satisfies the equation. A solution is an ordered pair which satisfies the equation. the solution is always written as an ordered pair. Now, do we have any other solution for this equation? Let's check whether 1, 4 is a solution or not. This says that 1, 4 is also a solution to the equation 4x plus 2y equals 12. There is a clear way of finding a minimum of two solutions to a given equation. Let's try it out with the same equation. Let's substitute 0 for x and find the value of y. Therefore, the solution is the ordered pair 0, 6. We can try it out with y substituted as 0. Let's see how the calculation is done. Now you can say that the ordered pair 3, 0 is another solution for the equation. Now the solutions of the equation are In general, any linear equation in two variables will have infinitely many solutions. Welcome to the lesson on graphical representation of linear equations in two variables. At the end of this lesson, you will be able to plot a linear equation in two variables on a Cartesian plane. You will also be able to determine the equation of lines that are parallel to the x-axis and the y-axis. Before learning how to represent a linear equation in two variables, let's review our understanding of its definition. An equation in the form of ax plus by plus c equals 0, where a, b and c are real numbers and a and b are not both 0, is called a linear equation in two variables. Such an equation has infinite number of solutions. For example, consider the equation x plus 3y minus 6 equals 0. It is a linear equation in two variables. To represent this equation graphically, we have to find at least two solutions. The solutions of a linear equation can be obtained by substituting different values for x in the equation to find the corresponding values of y. Let's use the values of x provided in this table. Generally, small numbers are chosen so that the calculations are easy. We'll begin by substituting minus 6 as x in the equation and solve it. The value of y obtained is 4. Similarly, we can substitute the other values of x in the equation and obtain the corresponding values of y. The values of x and y are represented as an ordered pair. In this case, the ordered pair minus 6, 4 is a solution of the equation x plus 3y equals 6. The graph of this equation can be obtained by plotting these ordered pairs. If we draw a line passing through all these points, a straight line is obtained. This line represents the graph of the linear equation x plus 3y equals 6. It is general practice to write the equation along the line it represents. There are other points that also lie on the line. For example, the point 3, 1. Let's verify by substituting 3, 1 in the equation. The coordinates of this point also satisfy the linear equation, so we can say that 3, 1 is also a solution of the linear equation. Hence, all points that lie on this line are solutions of this linear equation. Now, let's take another point that does not lie on the line. For example, the point 1, 2. Let's substitute x as 1 and y as 2 in the left-hand side of the equation. Here, the left-hand side is not equal to the right-hand side of the equation. Since these values do not satisfy the linear equation, 1, 2 is not the solution of this linear equation. Let's consider another equation, 4x minus 3y plus 12 equals 0. To plot the graph of this equation, we'll first find its solutions algebraically and then plot the points on the graph. Instead of randomly choosing values for x, we'll substitute 0 as the value of x in the equation and simplify. Please take note of the simplification steps. The value of y obtained is 4. Thus, 0, 4 is the solution of the equation 4x minus 3y plus 12 equals 0. Next, let's determine another solution for the equation. This time, we'll substitute 0 as the value of y in the equation and simplify it. Please take note of the simplification steps. The value of x thus obtained is minus 3. We can write the solution as minus 3, 0. So, we have two ordered pairs as the solutions for the linear equation. Let's plot these points on the graph. On passing a line through these points, the graph of the equation is obtained. This line represents the linear equation 4x minus 3y plus 12 equals 0. Remember, all points that lie on the same line are solutions of this linear equation. After solving the examples, we can conclude that any linear equation of the form ax plus by plus c equals 0 represents a straight line on the graph. The word linear originates from the fact that the graph of a linear equation in two variables is represented by a straight line. Every point that satisfies the linear equation lies on the line. Every point that lies on the line is the solution of the linear equation, and a point that does not lie on the line is not a solution of the linear equation. Consider the two sets of ordered pairs plotted on the graph here. Let's draw a line passing through these 2 points. As you can see, the line obtained is parallel to the y-axis. On examining, you will see that the x-coordinates of both these points are 1, which means the equation of this line can be given by x equals 1. Similarly, we can draw other lines that are parallel to the y-axis. The equations of these lines can be given by x equals 2, x equals minus 3, and x equals 5. On generalizing, we can represent any line parallel to the y-axis as x equals k. Now, what happens in case of the equation x equals 0? The line coincides with the y-axis, so we say that the equation of y-axis can be given by x equals 0. Similarly, can we draw lines parallel to the x-axis? Of course, yes. You can observe that these lines are parallel to the x-axis. The equation of any line parallel to x-axis is of the form y equals k. If we plot the equation y equals 0, we get a line that coincides with the x-axis. Therefore, we can say that y equals 0 is the equation of the x-axis.